This video answers the question, what happens if we add each number in this sequence up? All right? What happens if we take 1/2 plus 1/4 plus 1/8 plus 1/16 plus 1/32 plus 1/64 plus all the way to infinity? What's going to happen? Well, when we add up all the entries in a sequence, we call that a series, and we write like this. You have the summation symbol that looks like an E. The bottom shows you where you're going to start. We're going to start at n equals 1. And the top is going to show you where we're going. We're going to infinity. And this 1/2 to the n is called our argument. So notice if we plug in 1, that gives us a half. If we plug in 2 for n, that gives us a fourth. If we plug in 3 for n, that gives us an eighth, and so on and so forth. And the summation symbol, the E, means we're going to add them all up. Okay, so to find the sums, we can't actually do that to infinity. That's going to take an infinite amount of time just to add up all those fractions to infinity. So instead, I'm going to find the partial sums. And to do that, I'm going to show you this. We have this 1 by 1 square, and we're going to slowly add up all the pieces to the square. So let's start with 1/2. Here is our first term, 1/2, and I'm going to add to it 1/4. That partial sum is 3/4. I've shaded in 3/4 of this 1 by 1 square. Now if I add 1/8, that partial sum is 7/8 because 7/8 of the square is shaded in. If I add 1/16, now I've shaded in 15/16 of the square, so the partial sum is 15/16. We can keep going. We can add 1 over 32, 1 over 64, 1 over 128, and it's going to get so small that we can't even see the boxes anymore. But what's going to happen is it's never going to go outside of the main box. This 1 by 1 square is kind of going to be the boundary of our fractions, because the fractions are going to get so small, but it's never going to exit that box. So what we can say, and this is really weird, but this summation of infinite numbers is equal to 1. An infinite number of positive numbers can still add up to a finite number. In this case, our series is equal to 1.